Alright, welcome to my video on properties of logarithms. Now I have a couple of different parts to this video series, so you're going to see this introduction is going to be the same for all of the logarithm problems, but I did want you to understand a couple of things. First is that logarithms are really nothing more than an alternative way to keep track of exponents. Now sometimes I refer to logarithms as like the land of the logs, okay, like a totally different universe or a totally different country. Okay, the rules, they're kind of similar, but they're also kind of different. Okay, so I want you to pay attention to those differences. For example, when you were dealing with exponents, right, and you were multiplying two terms, like if you were multiplying x times x, that gave you x squared. Now, that was like saying x to the first times x to the first, and then taking 1 plus 1 and adding them to make 2, giving you x squared. So I want you to pay attention to logarithms in the same way because they have a lot in common with the rules for exponents. Okay, so just pay attention to that. Addition, kind of like multiplication, and subtraction, kind of like division, so look for those similarities. Now, the final thing I'm going to leave you with is there are some additional tricky rules, okay, that come with this because you're going to need to be fluent in converting between what they call logarithmic notation and exponential notation. So I want you to pay attention to those times where you're flipping between the two. And I want you to also pay attention to things like the bump rule, where you're actually converting between exponential and logarithmic notation, and also some of the other fun rules like the change of base rule and what's another one? There's one that also has like where the log of a number to that same base, like for example log of 10 to base 10. Alright, paying attention to those kinds of situations and what they mean. So there's a lot of different properties that you're going to learn about, and I want you to just get what you get from each part and just keep practicing is my best advice, okay? Stop the video when you need to, go back and practice, and I'm very sure that you too will be able to navigate through the land of the logs. All right, here we go. Hello everybody, we're going to now show you part 2 on the series of properties with logs. Get excited, we're about to do some fun stuff here. First is we're going to evaluate an expression, and we're going to use a very slick trick called the change of base rule. And basically the way that the change of base rule works is when you're given two numbers here like this, where you have an unusual base number, right? You don't have 10 as your normal log to the base of 10, right? You have log to the base of 5. If you want to evaluate this, what you can do is you can change it to log of 10. You can say log of 125 to the base 10 over log to the base 10 of 5. This is a totally legitimate move. So this is the change of base rule. We're changing the base from 5 to 10, and I picked 10 because guess what? That's what my calculator understands. So I like picking base 10. So if I want to evaluate this, what I do is I type in log of 125 divided by log of 5, and without even too much effort, I get my final answer is simple, 3. All right, let's apply the change of base rule over here to this situation and see what happens. This time we've got log to the base of 64, and we're taking the log base 64 of 4. So to apply the change of base rule, what we're going to do is we're going to take the log to the base 10 of 4, divide that by the log to the base 10 of 64. And again, using my calculator, I'm going to do the same thing. I'm going to take the log of 4, and I'm going to divide by the log of 64. So anytime that you don't see a 10, the calculator assumes that you want base 10. And here we get roughly 1/3, right? 0.33 repeating, right? 0.33. When you see 0.33 like that, that's basically 1/3. All right, so that's our answers over here. All right, I like to box my answers when I'm solving things because it makes it easier for the math teacher to give me points. All right, and I want my points, and then so do you. All right, next we're going to simplify a couple of expressions. So here we have two logs. They're subtracted from one another. So the way to simplify this is going to sound a little strange, but if you think about what we normally did with exponents, what happened when we divided exponents? We subtracted, right? When we had exponents where we had, like, let's say x squared divided by x to the first. When you had a division situation going on, you subtracted 2 minus 1. All right, that was what you did. Now, logarithms are a simplified way of dealing with exponents. So when you see a minus sign, what you're going to do is you're going to say log to the base 4. That's not going to change. But you're going to say x divided by y. All right? This is sometimes why I refer to the logarithms as like the land of logarithms, because the rules get really crazy, okay? Where subtraction becomes division. All right, let's take a look at the wackiness over here. Here you have log base 7b plus log 7 of c, right? So log base 7 of b plus log base 7 of c. Now, back in the day when you were dealing with exponents, if you had x squared times x squared, you got x to the 4th because you were adding the exponents, right? So guess what we're going to do if we add logarithms? That's right, we're going to multiply them. So we're going to take log to the base 7, and instead of writing log plus log, we're going to write b times c. Or you can even just write it as log to the base 7 of bc, right? Because the letters are multiplied by each other. So these are my two answers for the next two problems. All right, so that's simplifying expressions, basic properties of logs, just getting your feet wet. So there may be more problems you need to solve for your homework assignment. I'm just here to show you the basics. Now, if I were going to do the opposite, I can expand the expression, right? I can change something that was multiplication and change it to logarithms that add together. So I can say log to the base 6 plus log to the base 11. That's totally legit. And I don't have to write a base because they didn't write a base up here, so I assume that we're in base 10, which is a pretty safe assumption when you don't see a log number base there. Then this becomes our answer, so I'll put a box around that before I get ahead of myself. I was so eager to jump to that next problem. Anyway, patience. Okay, so now we have log of 2 over 7. All right, this is division, and you can see what we did when we had division. That came from subtracting logs. So let's do that. Let's take the log of 2 minus the log of 7. All right, so now you have the expression, the log expression, expanded now. You've written it in expanded form. All right, so this concludes part 2 of properties of logarithms. On this video, we showed you how to evaluate some expressions using a very slick trick called the change of base rule. I love that. Very easy way to solve stuff using your calculator. And we also switched between the expanded notation and also simplifying. So we went back and forth between an expanded notation and a more compact and condensed notation for logarithms. All right, so try to think. Subtraction's like division, and addition is like multiplication in this magical land of logs. Okay, you just got done watching a video on the properties of logarithms, so hopefully your logarithm kung fu is a little bit stronger than it was before. And all I can emphasize at the end of these videos is practice. Practice, practice until you know it in a way that you don't even have to think about it, okay? A lot of these rules are not natural, okay? things like the change of base rule and the bump rule, and even simple operations that you'd think, oh, okay, I'm just going to add these logs together, and then it turns out, hey, why am I multiplying these things, right? So there's a lot of rules that are kind of like a little different with logarithms, and you really do need to practice them in order to get better. So be sure that you get really good at converting between logarithmic notation and exponential notation. Make sure that you're becoming familiar with all those special rules, right? The bump rule and those kinds of things. And then finally, just keep practicing, okay? You're not going to get better overnight. Just give yourself some slack, right? Give yourself some patience. Be patient with yourself, and then just practice. And I'm sure you're going to be good at this in no time. All right. Good luck, and if you need more help, watch another video.